hidden in the background, like in your washing machine. It's going to have a motor. That's what turns it. With all the buttons that you hit on that washing machine and knobs you turn, a lot of these devices are hidden behind those covers. Okay? For a couple different reasons. They're not the prettiest thing to look at. And also, if you touch them, you can get shocked if you don't know what you're doing, where the wires are hooked up. It exposes to electricity. But as electricians, we have to be able to interact with those devices, troubleshoot them, install them, wire them, do all this different stuff. So what you're looking at is the trainer version of it. It might not look exactly like it is in the field because we have to protect the students because they're getting used to interacting with this stuff. So like you see the motors, they're behind a piece of plexiglass. So when it starts turning, they're not sticking their hand in there grabbing the shaft. If you look at the wires you see plugged in at some of the stations there, they're plugged in. They plug and play really quick and easy. They don't screw down with a screwdriver because we have to make it safe for the student. So that's the reason it looks slightly different. But we can simulate everything that you would see in the field. The devices you see on the bookshelves there are devices we can wire up to those motors, and they'll do those next semester. So they can hook all those components. You see little lights, little push buttons, contactors, switches, little motors, all these different things we can hook up to the bigger motors to control them. So the students get to play with those, get to take voltage measurements. They learn how to use the voltmeter to troubleshoot circuits later on, like an electrician would use. They learn how to follow wiring schematics, like you see here, different wiring schematics with resistors, switches. They have to take a piece of paper, wire it up correctly. If it's not wired up correctly, I teach them how to troubleshoot and figure out what the problem is. When they do wire it up correctly, I mess it up and still make them troubleshoot. Because let's face it, when an electrician goes out, he's either installing new work and has to make it work, or there's a problem. He didn't break it. They called him because something's broke, something's burned up. He's got to figure out what the problem is. So a lot of times when he's on the site, it's not working properly. That's the reason he's there. So he has to be able to learn how to interact with electrical schematics, analyze what's going on, use his voltmeter, and go through a process to figure out what the component is bad. Because different components go bad at different times, different scenarios, just like an automobile or anything else. So we've got about 4 or 5 classrooms, and I'm going to show you the different classrooms individually, and then we're going to sit down and do a lab together in one of the rooms at the very end. So this is one of the main rooms for electrical machines. They take 2 courses in this room. So let's move on down the hall now, and we're going to go to another couple classrooms. They're spread out a little bit.
Yeah, let me get in front of you so you can get my hand in there. I need about 2 months at work. I come back second semester. Nope. I'm going to leave it there until
So if y'all just want to walk around in here, we won't sit down here yet. We're going to quickly move to another room. If you want to walk around, the floor you're walking on that you think you're getting ready to fall, that is a floating floor. You're about that far above the concrete. That's so wires can get run between these benches easily to move stuff around, and we also use it to store stuff. But that's the reason it shakes a little bit, because it's about a foot off the concrete. All right? That's the way they built it in 1974, whenever this building was built. In this room here, if you walk by and look at it, when we move to the other room, this is our storage room for a lot of our components. You'll see the conduit, you'll see wire, you'll see all kinds of things in this room. This kind of materials closet that we pull material out of to use for the different classes and then have to put it back in there so we have different classes in different rooms. These desktop instruments you see here, students use a little board like that you're getting ready to use later on to wire a little circuit up. So they learn how to use the multimeter that I showed you a minute ago. This is a desktop multimeter compared to one you can hold in your hand. This is a power supply, DC power supply. This is an oscilloscope. Because let's face it, a desk you can put your hands on. It's tangible, right? You can see it. You can feel it. Can you see an electrical wave? You cannot, right? So we have to have these oscilloscopes to show what the electrical wave looks like. So we can talk about how it's built, the variations of it, how you manipulate it, and change different things. So that's the reason we have to have this test equipment, so we can create it and see how it works. Because we can't show you a block of wood, say this is a square, this is a rectangle, this is a circle, or different things, because you can't put your hands on it. When you get shocked, you definitely feel it, okay? But you can't really see it. You see what I mean? So we have this test equipment so the students can learn the theory of current, resistance, and voltage, because we have to tell them that basic understanding of the way the electrical field works, so then when we build their knowledge, they know where it came from. They have to have the foundation to support the more complicated stuff we get to later on. So this is another one of our test labs. If you walk through that door, we're going to walk into our biggest classroom. I'm going to show you what we do.
I'm wondering now, like everywhere else,
Watch the steps.
I've been here like 80-some years and I've never felt through. So come on in. Come on in.
Oh, okay.
Oh, that lift. Oh, okay. This is our biggest classroom. There's several classes taught here. For the program, the students have to take 2 physics courses as well. I teach both the physics courses through the program, so this is the classroom for the physics courses. That's some of the stuff on the board from yesterday, a problem we were working. This is a commercial wiring training. They have to take a commercial wiring class. The students at the beginning of the semester start with this gutted. They have to run all the wires, label everything, hook all these devices up. This is more like what you would see in the field, but it's the same type of components that we had down in the machines lab. Except now this is what it looks like in the field, because I've built their knowledge. They're working safer, telling them how to treat this stuff, how to work safely, but now they're turning screwdrivers, hooking wires up, putting labels on. When they get done, this is basically a simulated garage door. When you hit the open button, it's going to open until it hits this little limit switch, and then it's going to shut off. Then when you hit the close button, it's going to go down and hit the limit switch and cut off. So they've got to start it out with just the cabinets, and then I give them an electrical schematic. They use the electrical schematic to wire everything up. They do it correctly, it works fine. If it doesn't work correctly, well then I have to show them how to troubleshoot it. So then, because that's what an electrician does most of the time, is troubleshoot problems. If they do wire it up correctly, well then that's where I come in, I mess it up. I tell them to leave the room, I cut a wire, blow a fuse, move a wire, I screw it up, they come back in, I won't tell them what it is. I say fix it. Because when they go to the field, there's a problem, the person operating that equipment, they just know they're supposed to hit the button because they're not an electrician, they don't know what's going on after that. The electrician has to figure out what the problem is. So then they have to learn how to troubleshoot based on the electrical schematic, their meter, and what I've taught them in order to figure out what the problem is. So all these different little boxes are different labs they can do throughout the semester for commercial wiring. Also for commercial wiring, you see these metal pieces of, it's called unistrut, voltage to block wall. That's so that you see that conduit in the side there. I teach them how to bend conduit and run it like you see in commercial and industrial applications, because you have to put 90s and offsets and different bends to get from point A to point B. The conduit has to be bent. Well, that's based on nothing more than trigonometry. So I teach them the trigonometry behind how to bend the conduit, show them how to use the pan benders in order to bend the conduit so they can hook the 2 boxes together and it looks professional with high quality bends. So that's part of commercial wiring as well. There's none up there right now because they just took it down because the next group's getting ready to start wiring it, getting ready to run all the conduit. This is the selected topics class that's taught also this semester, where they learn how to run Ethernet cables, coax cables. When they start the semester, this is pretty much a stud wall. All the students have run all these wires, put the outlets in, terminated the ends, wired the panel up. They do it all. They have to test it. We hook it to different VCRs and TVs and different things to test it throughout the semester that you see sitting back there on the table. Towards the end of the semester, we're about halfway through, they hook up a couple of cameras, a couple of wireless devices, but it gets them using their hands, using tools. Because let's face it, like I've told the other groups 20 or 30 years ago, most everybody knew how to use a screwdriver, a tape measure, different things like that. You can't say that nowadays. Sometimes I hand students a screwdriver and I'm more scared they're going to hurt themselves with it than actually use it properly, okay? It's just that they don't have that experience. Whereas 20 or 30 years ago, you were sort of raised that way. I mean, let's face it, you were outside a lot more interacting with things with your hands.
That's right.
If the hardest things they turn now is a joystick, well, you're not. A screwdriver is a foreign object to you. Okay.
So called out.
So now what I want to do is I want y'all to walk through. I'm going to show you the residential wiring lab, and then we're going to go to the other last classroom where we're going to do a little lab together.
Step down. A double step down.
It's a quarter scale house, basically. The students in the residential class, this is their lab. You can walk all through it if you want to. They learn to wire different rooms, Romex, lights, receptacles, GFCIs, switches. Each person basically has a little station, like this is one little simple lab right to begin with, where they have their schematic on the other side, where they hook a keyless and a single pole switch up. Once they've got done wiring it up, the instructor inspects it to make sure it was wired up correctly, the code, and then they hook live power to it, flip the switch, make sure the light comes on, the switch works like it should. So as they get through the semester, these labs get more and more complicated. Like this is a beginner type lab. Then as they get a little bit further, see now we've got three-way switches and a four-way switch, so it gets more complicated. It's like in your living room where you can flip one switch going in the room. When you walk out of the room, you flip another switch to cut the light off, right? Well, that's got to be wired a certain way, so they can simulate all that and test the student's knowledge of following the schematics. And get more and more complicated. As they get towards the end of the semester, then they'll have maybe 10 different switches and 15 different receptacles hooked up, a bunch of different things to simulate what's going on. But this is Romex that you see here that's running the walls of your house. Flexible, the wires are already put in it. One thing I've told the other groups, and I tell people all the time, is the electrical industry, when I train these students, is similar. I relate it to the medical field, doctors. Doctors have a specialty, right, that they go into. When my students graduate, if they're going to wire houses, they're going to deal with stuff like this. They're not going to deal a lot with electric machines and all the stuff you see in that first room. You don't see a lot of that in the house, right? If they're going to go work at Nutrien, Domtar, or Warehouser, are they going to see Romex? No. They're going to see the machine stuff, right? And the conduit and those panels in the commercial wiring. They're not going to see much residential. If they're going to work for Tideland, they're going to see like power line type stuff. They're not going to see Romex. If they go work at a place as a PLC technician that we're going to get to in a minute, they're not going to see Romex. So I have to teach them a little about every discipline within the electrical field, because I don't know where they're going to work, but I want them exposed to it all enough so if they get hired by this company and they jump to this company, they've got they've been exposed to it, they've messed with it a little, they've used their hands. So that's the reason, if you notice, we've gone from room to room, it's still electrical, but it's vast differences between them, okay? But the theory is all the same. It's basically how you're packaging it, okay? I flip the switch, a light comes on. I flip the switch, a motor comes on. Still electricity is powering it. Okay? So what I want to do now, if you don't have any questions in this room, is follow me to the last classroom, and that's where we're going to do all the lab together. So we can run wires, connect the lab, move equipment around, and store stuff already. Oh, okay. Yeah, we got to store a lot of stuff. All right, everybody find a seat and wake the computer up. Just click on the mouse, the space bar. It's hibernating. Or you can shake it. If that's what you do to people in your house, you wake them up, you shake them. All right. Don't do anything, just wake it up. I'm going to show you, I'm going to see who's on the right program and who's not. We're going to talk about it. Don't sit at that one. Move to the, never had a problem with that one earlier, if you don't mind. Any other one than that, that's the only one I had a problem with in the last group. The group before that, it worked fine, but then all of a sudden it didn't want to work. Let's see here. I'm going. We'll double flip right there for me. Okay. That's right there. Let's see here. Let me see here. Get back to this. All right. You will maximize that window for me and just leave it right there. You can hit no. You're good, you're good, you're good. And you just click sign in, you should be, and you're good, okay? All right. What we're going to do now is we're going to wire a little circuit up with the board in front of you and those components, and I'm going to show you how to do it step by step. If you've never done it, never seen anything, don't worry about it. I'm going to show you every little problem, every little detail. If you have a problem, I'll come help you fix it.
When I hit no, it took me back here.
Oh, it did? Okay. Double click on this right there, that little green thing. double click on that. And then it should have something maybe add you a tip. Yeah, you're good. Okay? Alright, so this is the software that we're going to use. We're going to wire our little electrical circuit up, and then we're going to type in some code that's going to control that electrical circuit. Okay? Remember what I said earlier when I said when you go to your washing machine, you hit a button and it goes through all the cycles by itself? We're going to do something very similar to that. We're going to wire a little circuit up, then we're going to create a program, we're going to hit a button and it's going to flash the light. Okay? So what we got to do first is I want to show you how to wire it up. So everybody at the top where it says help, click on that if you don't mind. And it should pop up a little box. And you see one of them that says, what's a microcontroller PDF?
Yes.
Click on that. And it should open a PDF up on your screen like you see here. I want you to type in page number 71 for me up there at the top. And you should see what I have on the overhead projector. That's what you should see. You type in 71 and hit enter. Okay. Everybody got that? All right. We got 71. This is the schematic we're going to use to wire this circuit up. Now, if you look down, you've got 3 resistors on your table, and if they're leave the push button alone. Don't mess with it.
Wait a minute, where did I can't see it.
See right here? Don't mess with that.
Okay.
That's the don't touch device, okay? I don't want that moved.
Okay.
But there's other components. There should be 3 resistors and 2 pieces of wire. If they're on the board, pull those off and set them to the side. And the LED. Just set them on the table beside you, because we're going to use them as we go through it. You should have 3 resistors, 2 wires, and the LED, which is that little red little bulb thing. Everybody got that? Okay. Now, if you look at the resistors, they have different colors. The different colors help us tell what value it is. And the students in the program, we go over this early on, but I'm having to skip some steps with you all because I only have like 20 minutes. Okay? So, the resistor I want you to grab is the one that is red, red, brown. Grab that resistor. Now look at me up here on the board. That resistor has got to be plugged in this hole and this hole. You can look at your picture on your screen if you want to, but here, this is the resistor we're putting in. That one right there. Put that one resistor in. And you can look right and see how it's got it right now. Yeah.
It's gonna be in P3.
Good.
Chad.
Now, it's got to be in the black hole right there. See that's in the black hole right there?
You were.
There you go.
Okay. Got it.
If you have problems seeing it, you need some help, let me know. Got it?
Zero.
Yeah, it starts out at 0, 1, 2, 3. It's just a little bit. Don't press it too hard. Push it on that thing. Yep, put it in. Put, just like the picture. Push that one right there and put the other one right there. That's for this here, just like the picture, and then the one that's beside the P3. Yep.
Okay, P3 is.
Yep, the black hole. No, the black, see that P3 right there by the black hole, just like the picture. When you look at your picture there, see right there?
1, 2, 3.
Did they do it right?
That's it. Yeah, sort of. You got to see it's in that little black hole. P3, see you're in the white hole, so you got to go over to the P3 black hole.
Yes.
You got to go up 1, you got to go up 2.
You're welcome, dear.
You're off 1 hole. So it starts out at 0.
Okay.
But these, oh crap. Only these other wires out of the way so we don't get messed up. So, here. And then 0, 1, 2, 3. There you go. You're
I just hit.
0, 1, 2. Yep, you're good. Got it? Okay, so everybody good to go?
Not I lost one.
You stealing resistors?
It was just up.
Somebody get the metal tester.
Under something?
If it hit this floor, let me figure out which one it is. I'll get you another. It's the 10K. I got one.
Oh, she said something on my sleeve.
Oh yeah, you got stuck in you. Yeah, you are trying to walk with it.
Oh,
All right. All right, everybody's got that resistor hooked up?
Yep.
Yeah.
All right, now we're going to take a jumper wire. You got two wires, two just pieces of wire. You're going to go from here, from this hole, and you're going to go up in this top hole here.
Doesn't matter
Which color?
It doesn't matter the color. Whatever your favorite color is, use that.
Okay.
Doesn't matter the color. But one of the jumper wires.
Is that a P2? And then we go up to the P2 section.
It's the same thing I did as well.
Got it.
There you go. Yeah.
So you know, have you ever seen Rush Hour?
Yes.
Do you know when she had to undo the bomb and she was like
Oh, now you're getting detailed.
So okay, so there was a scene
It's been a long time.
where the female cop had to do like the bomb. She was trying to learn that new bomb.
Right. I'm not going to talk about bombs in school, but
That station, say that.
if anything with electrical device is going to be actually wired up, so it's very similar. You're wiring something up, right? Yes. Yeah. Yeah.
I see it on
No, that's fine. No. All right, everybody's got that jumper wire in?
Yes.
All right, the next thing we're going to do is we're going to take the resistor that is brown, black, orange, and go from this hole to up here. Put this resistor in right there. That's a 10K resistor. That's what those colors mean. 10,000 ohms.
1, 2, 3.
Anybody have any problems? Everybody got it?
Yes, ma'am.
We're getting there. The next wire we're going to hook up is your. Oh, we got to hold on. Who said hold on? All right, that's no problem. That's fine. That's fine where you got it. Plug it right there. Okay. Let's see what you got here. This little fine wire is for. Alright, there we go.
Thank you.
Next up, we're going to use our other wire, our other jumper wire, and we're going to go from here to here. The important thing is it's in the same row as the resistor. See, that's in that same row? So plug it in that hole, and then plug it in the black hole at the top, which is ground. That last jumper wire you got.
Oh.
Everybody got the jumper wire in? The next thing we're going to do is you should have one resistor left, and that should be yellow, violet, brown. That's a 470 ohm resistor. You're going to plug in P14, the black hole, and it's going to come across and tie here into this hole.
Got it.
Okay? Has everybody got that?
Yeah.
All right, everybody should have one thing left on their table. It's the LED. LED stands for light emitting diode. Okay? This is the hardest part of the whole thing we're going to do so far. Hold that, straighten the legs on that LED, and tell me which leg is longer and shorter. Do you see a longer and shorter leg?
Yes.
You don't have one? Is it stuck in your clothes too?
Might be under the computer.
All right, now you got. I'm gonna give you this one. All right. Does everybody see the longer legs? All right. The longer leg is the positive side. The positive side is going to hook right here in this hole. Put the longer leg in this hole right there.
Okay.
Put the shorter leg in that ground hole in the back like you see in the screen.
Okay.
Everybody got that?
I like that. Okay.
Nothing's supposed to come on yet.
Go. I got it set.
We're still wiring it up. Has everybody got to that point?
Yes.
Okay, we have just wired this circuit up, okay? Now, if you notice, this is the electrical schematic, here and here. This is a picture of basically somebody already wired the circuit up, okay? Now, when I go over with my students, when you first start off, we have to build their knowledge and get them to learn electrical schematics. So initially, they have no clue what's going on, okay? As they progress through the program, I will not let them use this picture. I don't want them to use it, okay? Because that's not what they're going to see in the real world, in the field. I tell them this, I call this the monkey diagram. We use it initially, but I can train a monkey to hook it up when I do a picture like this. You're an electrician, you're going to have schematics. You're not going to have this when they call you to the house.
Right.
You see what I'm saying? Or industry. You're going to have an electrical diagram, if you have that. So I want you to sort of branch away from this, because this is wired up exactly like that is, except this is the electrical schematic. That's what I want them to learn how to read and use and troubleshoot. So if you notice right here, this is my push button right there, that little button right there. It's hooked to pin 3 that you just wired up. And your LED is hooked to what?
14.
14. This is not hooked to that. Okay? Where they're hooked together is in the software. We've got to create a computer program that says, if I hit the push button, I need the light to come on. That's the code we're getting ready to putting in. Okay? So we've done the field wiring, we call it. Now we have to write the computer code to make them mesh. Okay? So what I want you to do now is I want you to minimize the PDF. Don't exit out of it, just minimize it. And you should be back to your software screen.